I'm Anil Kumar, and in this video we will learn how to calculate value of a logarithmic expression using calculator. Well, you must have seen on a calculator there is a function which is log, and there is also a function which is ln. Log is to the base 10 and ln is a log with base e. We will now explore how to use these functions to calculate logarithmic of any value. But you can realize from here the log has to be to the base 10 to use your calculator, or the base could be e. Now, how can we do logarithm of any expression which does not have base of 10? Well, we need a formula to change its base, and that is what we are going to explore in this video. So here we have a change of base formula for you. We will derive this formula in next video, coming videos. The formula to change the base is log a of b is equals to log to the base 10 of b divided by log to the base 10 of a. Well, this could be any base. Since we want to use the calculator, it's better to keep 10 as the base. Now, it is not necessary for us to write 10. 10 is the default value for the base. So if I write log b divided by log a, it means the base is 10. Okay. Now the question here is, estimate and then apply the given formula to evaluate the following, right? So we have three different logarithmic expressions here. Round your answer to 4 decimal places. Correct. So first part is we need to estimate. So we have log 7 of 7, log 6 of 7, log 8 of 7. So what is your estimate for log 7 of 7? Well, you can pause the video, do the estimate, and also apply this formula and find the value correct to 4 decimal places using your calculator. Log 7 of 7. Well, you know it should be 1, correct? Log 6 of 7. Now, since 7 is slightly more than 6, we expect a value which is slightly greater than 1, correct? Because it is 6 of 7, correct? Now here it is log 8 of 7. We know log 8 of 8 is 1, so this value is less than 1, right? So it is definitely very close to 1, right? So it is less than 1, right? But close, correct? So that is our estimate. Now let us calculate these values. Of course, I can write log 7 of 7 using this formula as log to the base 10. So I'm not writing 10 now, of 7 divided by the base is log to the base 7, and when I do that I don't even have to use calculator. I will get 1, correct? Now in this particular case, if I apply the formula, I get log of 7 divided by log of 6, and here I get log of 7 divided by log of 8. Now let us use the calculator and find these results. So first one is log 7 divided by log 6. So we have log 7 bracket close divided by log 6 bracket close equals to, the value is 1.08603. Now rounding to 4 decimal places will be 1.0860, correct? Now let's do the next one, which is log of 7 divided by log of 8, and that is, as expected, 0.93578, correct? Rounding to 4 decimal places, 0.93, so 58, correct? So that is estimated value. So as expected, what you saw was log 6 of 7 is slightly more than 1. Do you see 1.08, right? So you could estimate as 1.1, and this value is slightly less than 1.9, correct? So at times you can make a good estimate also given the logarithmic function. Remember, the graph for the log function is kind of like this, right? So let me just sketch one for your reference here so that you get an idea, right? So it is kind of like this, where this value is 1. This value is 1 for, this value is 1 for x, and this value is 1 is the x-intercept, and the value 1 for y is when the base and a are both same, right? So log of b So when I say log a of b, I should write like this, right? So in that case, 1 is when b is same as a, right? So when b equals to a, I should write like this. So that way it works out. So if it is slightly, if the b value is slightly more than a, then we'll have more than 1. If it is less than a, we'll have less than 1, correct? And if it is a fraction, right, if I write b equals to half, then we get a negative value, correct? So that is how we can actually estimate. I hope this helps and gives you a very clear picture of values of logarithmic expressions. Thank you and all the best.